Hello students, this is the third part of the video from lesson light and about mirrors and reflection. In this part, I emphasized the ray diagrams, the drawing of ray diagrams, and this will help you to draw it with ease. You can go through my earlier video, that is part 2 of the same series, for sign conventions once again before starting to draw the ray diagrams. I am sure this will ease out the task. Now the most important part of this chapter. See, I have drawn the lines already so that the time is consumed less. See, we have to follow the rules like in sign conventions. There are so many light rays which come from the source of light and fall on the mirror. They also strike the object also. Now basically, from a source of light, there are millions of lights or thousands of light rays that are emerging. But we do not consider all the light rays at once. We take 4 types of light rays. Say this is case 1, this is case 2, this is case 3, and this is case 4. I consider a light ray that is coming parallel to the principal axis, because this is coming from the source of light, so this is the incident ray. After it strikes the mirror, concave mirror, it will bend towards the normal and will pass through the focus. This is the pole of the mirror. Now, this ray will go this side. So one condition, it says that when the light ray is incident on the mirror, which is parallel to principal axis, it bends towards the focus or it passes through the focus. अब बिल्कुल ऐसा ही हम कॉन्वेक्स मिरर में देखेंगे. कॉन्वेक्स मिरर में भी ये इंसिडेंट रे है, ये पैरेलल टू प्रिंसिपल एक्सिस है, ये पोल है, पैरेलल टू प्रिंसिपल एक्सिस है. बट आप देखो यहाँ से फर्क है. इट विल नॉट बेंड टुवर्ड्स द प्रिंसिपल एक्सिस, बट रादर इट वुड डाइवर्ज. But it would diverge in a way that it is incident or is directed in the direction of the focus only behind the mirror. Because this is a mirror, convex mirror, because this is the part of the mirror, of this sphere, and this is the part of this sphere. So its focus lies on this side and the focus of the convex mirror lies on other side. So like in sign conventions also we saw that if the distance measured from pole to focus in this side, that is in the opposite direction to the direction of the incident ray, then it would be taken as negative. So the focus would be negative, focal length, sorry. And in this case, because we'll again start from the pole of the mirror and it is on the right hand side, that is the direction of the incident ray. So this distance will be taken as positive. Therefore, concave mirror has a negative focal length while the convex mirror has a positive focal length. Now we see the second case. We consider a ray of light that is passing through the focus. This is the incident ray. It is coming in the direction of the focus. After reflecting from the concave mirror, it will reflect and will become parallel to the principal axis. The same case in case of convex mirror. This is the incident ray that is in the direction of the focus, but of course on the other side, see the direction, it is on the direction of the focus, but it will have a property that it will not bend towards the principal axis, it will reflect but will become parallel to the principal axis. So these 2 points are just the opposite of each other. If the ray of light is incident parallel to the principal axis, it will pass through focus. If it is incident in the direction of the focus, it will become parallel after reflection from the mirror. But we have to keep it in mind that if we are considering the case of a concave mirror, it is a converging mirror, so the ray has to bend towards the normal. But if it is a convex mirror, so it will bend away from the normal because it is a diverging mirror. Now we take the third case. It is slightly easier. This is C. That is center of curvature or radius of curvature. So, if a ray of light is incident on the mirror, concave mirror, which is in the direction of the radius of curvature, it does not deviate from its usual path. ये अपना रास्ता बदलती नहीं है. यानी अगर मान लीजिए मैं ये इंसिडेंट रे यहाँ पर एरो लगाती हूँ, ये गलत लगा दिया मैंने, तो ये इंसिडेंट रे रिफ्लेक्ट भी उसी डायरेक्शन में होगी, यानी इसका रास्ता बदलेगा नहीं. यहाँ भी वैसा ही है. दिस इज द पोल, this is the ray that is incident in the direction of the center of curvature, but of course on the other side it would bend in the same direction backwards. Now the fourth case and the final case. The ray of light that is incident on the pole of the mirror. So you can see this is the angle of incidence. If you remember laws of reflection, the angle of incidence is equal to the angle of reflection. So light ray, this is incident ray, this would be reflected ray, but it would form the same measurement of the reflected angle of reflection as angle of incidence. So if this is angle of incidence and this is angle of reflection. Same is the case here. This is angle of incidence, this is incident ray, this is reflected ray, and this is the angle of reflection. So, when any image is to be formed, it is not necessary that we consider all the hundreds and thousands and millions of rays. We have an option of selecting any 2 out of these 4 rays. We can take this ray and this ray. We can take this or this. We can take this or this. Any which is actually possible to be drawn in that case. Real and inverted हमेशा principal axis के नीचे बनेगी. So this would be negative. Always remember that you have to draw the arrows on the incident ray and the reflected ray also. The second case we take, when the object is placed beyond C. Now what is C? F you know. C and F has a relation. When we draw a mirror, we should always take some distance or measurement in it and draw an arc. And the same distance we have to measure again, and that would be C, because C is twice the focal length. That is, this is the focal length. So this has to be twice the focus. So this you have to take care of. So if the object is beyond C and the ray of light that we are considering is parallel to the principal axis, as the rule says, it will bend towards the principal axis and will pass through focus. Now we have to take another line, that is either the ray that is coming through the center of curvature, or we can take another ray which is coming through the focus. So see, we are taking the another ray that is coming from the focus. After reflection from the mirror, it will become parallel as the rule says. Now see, the two meet at this point. So this is the point of image formation. So we will draw a line this way. So this is the object image. Now we will draw the arrows. This is the reflected ray, this is the incident ray, this is next incident ray, and this is the reflected ray. So you can see the image is formed between C and F. So now the position would be between C and F. The nature would be, again, it is inverted, so it has to be real, because a real image is always inverted. The size, you can see the size of the object is more than the size of the image. So we can say that the image is diminished. Now the same way, U, as already discussed, always negative, H always positive, V. So this is V between P and this point. So this would also be negative. F, for concave mirror, it is always negative, and H dash below the principal axis. So this is also negative. This is the third case when the object is placed at C. You can see the object is at C. This is the ray that is incident in the direction, and it is parallel to the principal axis. So as earlier, it will bend in a way so as to pass through focus. So this is the reflected ray. The other ray we have taken as passing through the focus. It will become parallel to the principal axis after reflecting from the mirror. So you can see that the two meet at this point where the object was already kept, but the only difference is that it was upright and this is inverted. So I've already written the position of the image at C. Nature उल्टी है इसलिए real and inverted, और size same as object. these signs, 1C, negative always, positive always, V, from P to point of image, negative, F, again, always negative, H, positive, and H dash below the principal axis, negative. Now case 4 children, when the object is placed between C and F. This is C, this is F. The distance between the pole and focus should be exactly equal to the distance between focus and center of curvature. Always remember it. We have taken, this is the object, the ray parallel to principal axis, bends towards principal axis in such a way that it passes through focus. So this is the reflected ray. The second ray I've already drawn, that is passing through the focus. So as you know, it will bend and will become parallel to principal axis. Now these two rays, wherever they will meet, that would be the point of image formation. It means the image is formed at this point. Always remember children, because we have taken the rays arising from the tip of the object, so this point is again the point where the tip has to be drawn. So you have to be cautious. The arrow should point downwards. Sometimes children do some mistake. So it has to be like this. Now see, the position is beyond C. Nature उल्टी बनी है, it would be real and inverted. जब भी inverted होगा तो real होगा ही होगा. Size, it is larger than the object, or you can say magnified. U, always negative. V, again from P to this point is V, negative. Focus, focal length, negative. And height of image, negative. V from pole to the image. Now point of image is this. So this distance we are taken in the direction of the incident ray, that is on the right hand side of the pole. So V in this case would be positive. Focal length from pole to focus, again in the right hand direction, so it would also be positive. H is always positive. H dash, because this is virtual and erect, so this would also be positive. Focus of a concave mirror, focal length is always positive and it is above the principal axis, so it is also positive.